You need to hear this if you're a tech enthusiast. Imagine a world without banks, without central authorities controlling everything. No more waiting in long lines or dealing with bureaucratic red tape. This is the promise of blockchain, a revolutionary technology that is transforming how we think about trust and transactions. It offers a new way to handle data and ensure its integrity. Blockchain is a secure, transparent, and tamper-proof way to record and verify information. Every transaction is encrypted and linked to the previous one, creating an unbreakable chain. It's like a digital ledger that is distributed across a network of computers, making it virtually impossible to hack or manipulate. From cryptocurrencies like Bitcoin to supply chain management, the applications are vast and varied. And digital identity blockchain is poised to revolutionize various industries. Imagine a world where your identity is secure and transactions are seamless. It's a game changer for developers, opening up a world of possibilities for building secure, transparent, and decentralized applications. These applications can range from financial services to healthcare and beyond. Blockchain is still in its early stages, but its potential is immense. As more people and industries adopt this technology, its impact will only grow. Understanding how it works is crucial for anyone who wants to be a part of the digital revolution. The future is digital, and blockchain is at the forefront of this transformation. At the heart of blockchain lies the concept of decentralization. This fundamental principle is what sets blockchain apart from traditional systems. Unlike traditional systems where a central authority controls everything, blockchain distributes power among a network of computers. This means no single entity has control over the entire network. Imagine a network of computers, each holding a copy of the same ledger. This ledger is a record of all transactions that have ever taken place on the network. This distributed ledger is constantly updated and synchronized across all computers in the network. Every time a new transaction occurs, it is reflected in real time across the entire network. When a transaction occurs, it is broadcast to the entire network. This ensures that every computer in the network is aware of the transaction. Each computer verifies the transaction using complex mathematical algorithms. These algorithms ensure the authenticity and validity of the transaction. Once verified, the transaction is added to a block, which is then added to the blockchain. This process is secure and transparent. This decentralized approach eliminates the need for intermediaries like banks or governments, making transactions faster, cheaper, and more secure. It empowers individuals by giving them control over their own transactions. Blocks and nodes are fundamental components of blockchain technology. Blocks are like containers that store transaction data. Each block is linked to the previous block, forming a chain of blocks, hence the name blockchain. This chain of blocks is cryptographically secured, making it virtually impossible to alter any information within a block without being detected. Nodes are the computers that make up the blockchain network. Each node has a copy of the blockchain and works together to validate and add new blocks to the chain. This distributed nature ensures that no single entity has control over the blockchain, making it highly resistant to censorship and manipulation. Section 4. The Blockchain in Action, a step-by-step guide. Let's break down how a blockchain transaction works step by step. Understanding this process is crucial for anyone interested in the world of cryptocurrencies and blockchain technology. Imagine you want to send some cryptocurrency to a friend. This could be for anything from splitting a bill to sending a gift. First, you initiate a transaction from your digital wallet. This involves entering your friend's wallet address and the amount you wish to send. This transaction is broadcast to the network of nodes. These nodes are essentially computers that help maintain the blockchain network. Nodes verify the transaction using cryptographic keys and ensure you have sufficient funds. This step is crucial to prevent fraud and double spending. Once verified, the transaction is added to a block along with other transactions. This block is like a page in a digital ledger. The block is then added to the blockchain after a process called mining. Mining is the backbone of the blockchain, ensuring its integrity. Miners are specialized nodes that compete to solve complex mathematical problems. These problems require significant computational power. The first miner to solve the problem adds the block to the blockchain and receives a reward in the form of cryptocurrency. This incentivizes miners to maintain the network. This entire process ensures the security and integrity of the blockchain, making it a reliable and tamper-proof system for digital transactions. Section 5. Blockchain for developers, a world of opportunities. Blockchain technology presents a plethora of opportunities for software developers. One of the most exciting areas is the development of smart contracts. Smart contracts are self-executing contracts written in code and stored on the blockchain. They automate agreements between parties, eliminating the need for intermediaries and reducing the risk of disputes. Another promising area is the development of decentralized applications, or dApps. dApps are applications that run on a decentralized network, making them more secure, transparent, and resistant to censorship. From decentralized finance, or DeFi, to supply chain management and gaming, the possibilities for dApp development are endless. Section 6. Myths and challenges, separating fact from fiction. Despite its potential, blockchain technology is often surrounded by myths and misconceptions. One common myth is that blockchain is only for cryptocurrencies. While blockchain technology underpins cryptocurrencies like Bitcoin, its applications extend far beyond digital currencies. Another challenge is scalability. As the number of transactions on a blockchain network grows, it can lead to slower transaction speeds and higher fees. However, developers are actively working on solutions to improve blockchain scalability, such as Layer 2 scaling solutions and sharding. Section 7. Conclusion. Embracing the future of technology. Blockchain technology is still in its infancy, but its potential to revolutionize various industries is undeniable. From finance and supply chain management to healthcare and governance, blockchain has the power to create a more secure, transparent, and efficient future. For developers, blockchain presents a unique opportunity to be at the forefront of this technological revolution. By understanding the principles of blockchain and exploring its applications, developers can create innovative solutions that shape the future of our digital world. Embrace the potential of blockchain and join the journey towards a more decentralized and empowered future. If you enjoyed this video, don't forget to like, subscribe, and leave a comment below. Your support helps us bring you more insightful content.